Hi Year 5, it's Mr. Philpotts here with a maths lesson this morning. I am at the top of my garden and surrounded by my vegetable patches. More about that in a few minutes. But I want to get started with a number problem which you can discuss with people at home, have a think about it for yourselves. But basically it's an odd one out problem. I'm going to write three numbers up and I want you to think which of the three is the odd one out, and the important part that we're listening for is, can you give a reason why you think one of these numbers is the odd one out? So we've got 18 and 23 and 49. Of those three numbers, which one do you think is the odd one out? This is a good time to pause the video and have a think about it before I go on to discuss why one or all of the numbers might be an odd one out for a different reason. So if you just pause it now, Year 5, and now unpause it, we'll have a look. So the trick to this is all three of them could be the odd one out. Can you have a reason for each one? 18 could be the odd one out because it's the only even number on the board. I say the board, it's my daughter's easel and the back of some old wallpaper. So it's not quite the smart board, but it will do today. So 18 could be the odd one out because it's the only even number. Okay, 23 could be the odd one out because it's the only prime number on the board. So remember, prime number can only be divided by 1 and itself. So it only has those two factors, whereas the others have more. 49 could be the odd one out. Think about why. That's right, if you've got it, it is the only square number up there. 7 times 7 will give you 49. So all three could be chosen as the odd one out for different reasons. And it's the reasons that's the really important part. So I think it's number whatever, because that's how we should be approaching this problem. Right. Today we're going to have a look at a math skill that we have done before in Year 5, but it's something that's worth practicing, particularly as we move forward through the upper school, and it's definitely something that we're going to be using in lots of different areas of maths in the future. So we're going to be looking at long multiplication. Now, I've been using long multiplication myself recently. If I just try and move the camera, hopefully you can see, I don't know how clear it is, in my vegetable patch, or part of it, I've been growing some seeds, and to work out how many seeds I needed, I counted across the patch widthways and the length, and then I multiplied those two together to give me the total number of seeds that I was going to use in this particular patch. So on the left, for any gardening enthusiasts, we've got some swede, and on the right, just starting to come through, is the broccoli, and at the back there you can see some of my strawberries. So fingers crossed, over the next few months they will begin to be ready to be eaten with any luck. Right, so I've been using long multiplication in my garden. Now I'm going to teach you long multiplication also in my garden, which I never thought I'd be doing, but here we are. So if you remember long multiplication, that means we are multiplying 2 or 3 digits by at least 2 digits. If it's just by 1 digit, it's short multiplication. We're going to lay it out something like this. So if I have 119 and multiply that by 23, so this is my turn at the moment, just to remind you how to do it. Okay, I'm going to start with my 1, so we start on the right hand side. 3 times 9 is 27. Carry that 2, because that's 2 tens, into the next column. Then I'm going to go 3 times 1, which is 3, plus the 2 we carried, gives me 5. And then repeat it, 3 times 1, which is 3. Now, this is the bit where we sometimes slip up. 2 is actually representing 2 tens. So it is a multiple of 10. And for that reason, we need to put our 0 placeholder in. Easy thing to forget. Now we carry on as we did before. So 2 times 9 is 18. Carry that 1 across. 2 times 1 we know is 2, plus that 1 is 3, and then 2 times the final one in the hundreds column is also 2. Final step then is we add the two products that we've created. So 7 plus 0, starting in the ones column, is 7. 8 plus the 5 is 13. 3 plus 3 plus 1, as we carried our 1 there, is 7. And then 2, and there's nothing else left. So our answer is 2,737. Now we've done this a few times in year 5 this year, so hopefully that shouldn't be completely new to you. Now I'm going to give you a question, so it's your turn. So just bear with me whilst I move my board on as best I can. Okay, your turn looks a little bit like this. 200, so write this down as I say it, and 47 multiplied by 32. Okay, have a go at that. This is the time to pause the video because I'm going to go through it straight away. So you've paused it hopefully by now, had a go, remember your placeholder. Let's see what the product of these two numbers will be. So starting on the right, 2 times 7, 14, carry the 1. 2 times 4 is 8, plus 1 is 9, and then 2 times 2 is 4. Placeholder, because 3 is representing 3 tens. 3 times 7 we go now, is 21, carry that 2. 3 times 4 is 12, plus the 2 is 14, and 3 times 2 is 6, plus the 1 is 7. And then we add the two together, starting on the right with the ones again. 4 plus 0 is 4, 9 plus 1 is 10, 4 plus 4 is 8, and the one we carried will give us 9, and then there's only 7 in the thousands column. So our answer is 7,904. Now, if you're unsure, obviously you can go back and skip back in the video to see me talk through it again, to go through the steps. Have another go if you got it wrong, that's okay, because we learn from our mistakes, not a problem. Right, if you're feeling confident, I'm going to give you some chilies to have a go at, okay? And then if you get the chilies, you can email them into the year 5 address, so year5@frenchprimary.worcester.uk. It's on your handouts, on your newsletters, so you've seen it plenty of times. But I'd like to see your solutions to some of these. So chili 1, what I'd like you to do is to find some dice, or you can find a number generator on your phone. Can you have a go at creating a 2-digit by 2-digit problem? So if you roll the dice, you might get a 4 and a 6, and then roll it 2 more times, you might get a 2 and a 3. Can you multiply those together? Maybe compete with the parents, see who can get the highest product, who can get the lowest. Maybe there's more than one way of getting the same product, and have a competition. Maybe you create 3 questions each, and that'd be like 3 rounds, you know, the best of 3, whoever gets the highest, the most is the winner. But that'd be a lovely way just to keep practicing that skill. Chili 2, this one's a little bit different. You might have to tackle this with more of a problem solving mindset. I'm going to give you the product, so that's chili 1. Chili 2, the product is 1,332. Can you work out which 2 consecutive numbers multiply together to give you that product? So when I say consecutive, I mean one after the other. So it might be 4 and 5, 19 and 20, 47 and 48. Obviously it's none of those 3 examples, but hopefully that helps with the idea of finding 2 consecutive numbers. And again, if you find them, please email them to year 5. And in chili 3, I might struggle to write this on here, but I will have a go. So chili 3, what I'd like you to do is I'm going to put a star to represent a digit. So it's going to look a little bit like the long multiplication layout, so bear with me, or a cross I'll put to keep it simple. So it's 3 digits by 2 digits. Okay, then that's going to give us 4 digits there, and then the 0 is a placeholder obviously, and another set of digits, it's going to look like that. And then at the end, it's going to be a 5-digit number. 1, 2, 3, 4, 5. So 2 digits by 3 digits. Now, can you work out which the digits are? And you can only use a 2, a 3, a 5, and a 7.